Hi guys, welcome back to another CalcFly video. In this video, we're going to be talking about question 3 from 2019 AP Calculus for response portion. Alright, this is non-calculator permanent problem. In this problem, we're given this graph of f, and also we know that this f function is continuous function. We're going to be using this information on this closed interval -6 less than or equal to x less than or equal to 5. And also this graph consists of 2 line segments and 1/4 of a circle. And the center is 5, 3. And also it is known that we have this point on this graph, 3, 3 less than the square root of 5. Alright, in part A, it says we're given this definite integral from -6 to 5 f of x dx is equal to 7. And we're going to be finding this definite integral from -6 to -2 f of x dx. First of all, we can break this entire integral, definite integral, into 2 parts, into 2 pieces actually, like this. From -6 to -2 f of x dx plus from -2 to 5 f of x dx is going to be equal to integral from -6 to +5 f of x dx. Alright? So we know that this integral is equal to 7. Alright? And this is the actually integral that we're looking for. So from -6 to -2 f of x dx plus this integral -2 until 5 f of x dx. So -2 here until +5 right here. Actually, we're going to be, when we try to evaluate that definite integral, we're also being asked to find the area under the curve. Okay, so this curve and this curve. And definitely these 2 areas are going to have the same value, but the signs are different, so basically they're going to cancel each other out. Then we're going to be finding this area and this area again. They're the opposite signs, they're going to cancel each other out. So what we're being asked to find is actually to be able to find the area under this trapezoid, okay, and also under this area. If you want to find this area, first you need to find the area of this right triangle from 2 to 5 and subtract the area of quarter circle from that area to be able to get this area. All right. So basically, so when we do that, that area is going to be equal to, so this area, this total area in red is going to be equal to 2 plus 9 minus 9 pi over 4. Okay, so if I put it over here, we're going to get 9 minus 9 pi over 4. So we're going to treat this definite integral as like a variable that we would like to solve for. So we need to move this piece over here. So we get definite integral from -6 to -2 f of x dx is going to be equal to, finally, 9 pi over 4 minus 4. So that's the area from -6 to, -6, so right here, so -2. All right, in part B, so let's move on to part B. In part B, we are being asked to figure out this definite integral. So basically, this definite integral could be written, as from 3 to 5 2 f prime of x dx plus from 3 to 5 4 dx. Okay, so basically if I put these 2 out front, we're going to get 2 times integral from 3 to 5 f prime x dx, and plus, if I take the integral of this 4, we're going to get 4x from 3 to 5. So basically, for the first integral, we're going to be applying the first fundamental theorem of calculus. Let's remember that from a to b, f prime x dx is going to be equal to f of b minus f of a. So we're going to do the exactly same thing. So 2 times parentheses f of 5 minus f of 3 and plus 4 times 5 minus 4 times 3. So 2 times f of 5 is going to be equal to 0 and f of 3 is going to be equal to 3 minus square root of 5 plus 4 times 5 is 20, and 4 times 3 is 12, so 20 minus 12 is going to be 8, so we're going to put 8 over here. So this is going to be equal to negative 6 plus 2 square root of 5 plus 8. So my final answer is going to be equal to 2 plus 2 square root of 5. So that's the answer to part B. So we've evaluated that definite integral. Alright, let's move on to part C. In part C, we're being asked to figure out the absolute maximum value of g on the interval. And also notice that the g is defined to be like this, from negative 2 to x f of t dt. Alright, so let me clean up the board first, and let's focus on part C. Okay, so if g of x is defined to be this way, from negative 2 to x f of t dt, and if I differentiate both sides, we're going to get g prime x is going to be equal to f of x. Okay, so basically every f of x values are going to be also the g prime x values. Alright, so it says find the absolute maximum value of g. So if I want to find the absolute maximum value of g, and this is related to first derivative, so we're going to set this expression equal to 0. So when I set this expression equal to 0, what I'm going to come across, the x-intercept as x-intercepts. So x equals negative 1, x equals 1/2, and x equals positive 5. So now we have to analyze these values in the first function, so g of x function. So basically x and g of x. So let's put the x values. The first one is negative 1, the second one is 1/2 and 5, and also we need to put that negative 2 value also. So when we plug in negative 1 into g function, the result is going to be equal to, from negative 2 to negative 1 f of t dt. So when we evaluate that, we're going to get 1/2. So same thing, if I do the same thing for 1/2, the result, g of 1/2, is going to be equal to negative 1/4. And then g of 5 is going to be equal to 11 minus 9 pi over 4. And then lastly, g of negative 2 is going to be equal to, 0. So from here, on the interval, this is my reasoning, on the interval, negative 2 less than or equal to x less than or equal to 5, the absolute maximum must occur at x equals 5. So and also absolute maximum value will be equal to g of 5 is equal to 11 minus 9 pi over 4. Alright, this is my absolute maximum value. Alright, so this is part C. Alright, so let's move on to part D. In part D, we're being asked to evaluate this limit as x approaches 1. So I guess it's pretty safe to apply the plug-in method, so let's do that. Let me wipe off the board. So if we apply the plug-in method, the things we're going to get is equals, basically I'm going to put x equals 1 into the function, so this is going to be equal to 10 to the power of 1 minus 3 times f prime 1, and divided by f of 1 minus arctangent 1. So basically, first of all, this arctangent 1 can be also written as inverse tangent 1. So if I set this equal to x, from here tangent x is going to be equal to positive 1. So basically, from the definition of a tangent function, tangent will take on the value of 1, at only x equals pi over 4. So basically arctangent 1 is equal to pi over 4. Alright, so equals 10 minus 3 times f prime 1. So the f prime 1 is 2, so 3 times 2 divided by f of 1 is going to be equal to 1, so 1 minus pi over 4. If I simplify this expression, and we're going to get this result as the simplest form, which is 16 divided by 4 minus pi. Okay, so for part D, we've just applied the plug-in method, and then we arrived at this answer, 16 divided by 4 minus pi. Alright guys, in this video we've done the question 3 from 2019 AP Calculus for response portion. And thanks so much for watching. Don't forget to subscribe, like, share, and comment. Bye-bye.